Welcome to the second part of this series. You'll be pleased to know the audio quality is a lot better in this one because I managed to fix a setting in OBS. For those that didn't watch the first part or didn't write down all of the code, I'm going to put links to the code of both parts in the description. So anyway, the focus of this part will be rendering isometric tiles, and we're going to be looking to do that both as a batch and iteratively. Before we start working on the code, it's probably a good idea to look at what kind of images we will draw to the screen. So here in Krita, I have an example of an isometric block, which we're going to render to the screen. First, it's important to talk about the dimensions of this block. Now, because we set our tile size to 64 pixels, the associated isometric polygon will have a height of 64 pixels, but a width that is double the height, so in this case 128 pixels. Now we need to calculate where we want to draw this tile, but since images are rectangular, we're actually looking for this left-hand corner. And to calculate this left-hand corner from an isometric polygon, we just need to calculate the minimum x value and the minimum y value, because in game screens, the y increases as it goes down. So calculating the min x and the min y of this isometric polygon will give us this position, this coordinate, and that will be our render position for the isometric tiles. So returning to the code, we're going to create a new folder for storing all of these images. So at the top level, we're going to create a folder called assets. And then within assets, we're going to create another folder called graphics. And this is the folder where we're going to place all of the images that we want to render into our game. Inside of this folder, I've put 3 images. These images I'm going to also include in the GitHub repository, so if you want to use exactly the same images as me, feel free to go ahead and download them. We'll be working with the block that I just showed you in Krita, a simple rock, and a simple tree. To start drawing these isometric tiles in our game, we're going to start off by rendering each of the isometric polygons that we created as these blocks. So to do that, we can go to game, and then we can go to world, and we're going to continue with this method grid to world. To find the render position for these tiles, we're going to do what I was talking about in Krita, and that's calculating the minimum x and the minimum y of this isometric polygon. So we can do min x equals min x for x, y in iso poly, and a very similar thing for the y. So min of y for x, y in iso poly. And then we can stick in this information into our dictionary that we return. So I'm going to call this render pos, and we have min x, min y. Before we can actually render these images into our game, we need to load them into pygame. So I'm going to create a new function called load images. And we're going to load the 3 images that I showed you before. So block, I'm going to use pygame.image.load, navigating to the correct directory, so that's assets, then graphics, then block.png. Repeat for the tree and the rock. Now that we have all 3 images loaded, we can return a dictionary of these 3 things. So we're going to use their names as keys as well. Okay, now that we have a method for loading these images, we can come up here and we can add this to our world class. So self.tiles equals self.load images. If we now go back to our game script, coming down to the draw section, we can start drawing these tiles into our game. So first we're going to extract the render position, and we're going to do exactly the same thing as before, but we're going to take out the render position, and then we can simply do self.screen.blit. In this case we're just going to be drawing the blocks, so in self.world we added this tiles, and inside tiles we can extract the block, and then we can draw it in the render position, but just like the isometric polygons we need to offset this. So we're going to do render pos the x part, and we're going to do plus self.width over 2, and also for the y, but with self.height over 4. Now we can run this code to see if it's actually drawn the isometric tiles. So running from main, and yeah, that's worked pretty nicely. We've drawn these isometric tiles in the correct position, so just on top of these isometric polygons. We can add a bit more variability to our world by randomly allocating some tiles to be trees and some tiles to be rocks. To do this, let's go back to our world script, and we're going to continue with this grid to world method. So first we need to import the random package, and then based on some random number generation, we're going to say some tiles are going to be trees and some tiles are going to be rocks. So if I first do r equals random.randint, and randomly selecting a number between 1 and 100, and we can say if r is less than or equal to 5, then tile equals tree. Else if r is less than or equal to 10, so tile equals rock. Otherwise we're just going to leave tile as blank, and that's just going to be our block. We can add this information into our output dictionary, so put tile here. Then now returning to the game, we are going to put in the draw logic here, so after the block has been drawn, and we're going to say that tile equals, again, the world dictionary, this time extracting the tile. And remember, if the tile is just a blank string, then we don't want to draw anything additional because we've already drawn the block. Otherwise we're going to draw another tile. So if tile is not equal to string, then we're going to do self.screen.blit. We are going to use the tiles dictionary inside of self.world, but this time we're going to just feed it tile because that's the string, and we're going to use exactly the same render position. So running main again, and this has kind of partially worked. We've managed to create some trees and rocks, but they're obviously being kind of rendered inside the blocks, and we want them to be stood on top. So to make this correction, we just basically need to kind of take away a bit of height on these objects. So going back to game, and then going into the Y position of the render position, we can do minus, and then we can extract or take the image, and from the image take the height of the image. So get height. Sorry, we're going quite far off the screen, so I'm just going to create a bit more room. Here's there we go. And then from the height, we want to take away the difference between the height and the height of an isometric polygon, which in our case is 64, which is the tile size. So now running this again, and now this has kind of worked as desired, and it's placing these trees and these rocks on top of the isometric blocks. The way we have rendered these tiles is an iterative way, so that's going through the grid of our world and rendering each piece individually. But we're doing this every single time the game loop updates. In our case, it's not hugely important because we're working with a pretty small grid, so 10 by 10, which is 100 draw calls every game loop update. But if our world was much bigger, and often in city builders it would be, and let's say our grid was 100 by 100, that means we'd be doing 10,000 draw calls every single update, which is most likely going to reduce our frame rate. So to avoid this problem, we want to draw the block tiles as a batch. So that means drawing multiple tiles with a single draw call. We can't draw the trees and rocks as a batch because we need to preserve the render ordering. Basically, that means that any image that is behind a rock, or in other terms has a Y value that is smaller than the Y value of the rock, will be rendered behind the rock, which is the basic idea of Y sorting. However, since everything in our game is going to be on top of the grass blocks and they have effectively 0 height, we don't need to Y sort them, so it's going to be a lot more efficient for us to just draw them all as a batch. So for doing a batch rendering of the grass blocks, the main idea for us is to create create a surface when we are initializing our world, and drawing all of these blocks to that surface once on initialization, and then every time the game updates and does the draw method, we're just going to draw this single surface that has all of the blocks already rendered to it. And so that will save us iterating and doing these draw calls to render these blocks individually. So to render all the blocks to a single surface, we can return to our world class, and we can make a new object called self.grassTiles, and we can define this as a pygame surface. And to make this easier to render in the correct position, I'm just going to define the surface to be to have the same dimensions as the screen, so the width and height, which we passed through here. Then, when we are creating our world, as we are iterating through the grid, we want to render these blocks to this surface, and then that way, after we've finished iterating, this grass tile surface will contain all of the blocks that we need in our game. So to do that, we can extract the render position like we've done previously. So we're taking from the world tile dictionary and just extracting the render position. And then we can do self.grasstiles.blit, and we're going to be taking one of the images in our self.tiles. So in this case we want the block, and actually we're going to have to move this above here, above self.world, because we need this inside of create world. And then we can blit this image at the render position. So again, taking the X and applying the offset, so it's going to be in the center of the screen, so that's self.width divided by 2, and then for the Y, self.height divided by 4. Okay, so returning to the game class, now that we have defined this grass tile surface, instead of drawing all of these blocks every iteration, we should be able to comment out this, and then directly after we have filled the screen, we should be able to draw this grass tile surface once every draw update. So we can do self.screen.blit, self.world.grasstiles, and because we made this surface to have the same dimensions as the screen, we can just pass in 0, 0 here, because then it will start rendering at the top left-hand corner of the screen. So running the game again, we can see that it's worked. We still have our green blocks, even though we commented out the draw calls in our when we iterated. So this has worked well. We're now like saving a bit on efficiency by drawing all of these blocks once, and it has no effect on the game's appearance, which is what we were looking for. The last thing I'm going to do to finish this part is just remove the grids that we drew originally, because we no longer need them, and it's going to make our game look a bit more game-like. So just checking this has worked, and there we go. Alright, that's it for part 2. The next part I'm going to be finishing off the foundations of the world, going to be expanding the world grid, we'll be writing the game's camera class, and a couple of bits and bobs, so that in the following parts we're able to start working on the city building aspects of the game. Alright, see you in the next part.